Have you ever wondered how the world would look if we could zoom in 1 billion times? Welcome to the world of the ultra-small, a world that's invisible to the naked eye but holds immense potential. This is the world of nanotechnology. So, what exactly is nanotechnology? It's a branch of technology that deals with dimensions and tolerances of less than 100 nanometers, especially the manipulation of individual atoms and molecules. To give you some perspective, a single nanometer is 1/1,000,000th of a meter. Yes, you heard that right, 1/1,000,000th. Now let's relate that to something a bit more tangible. Imagine a single sheet of paper. It's pretty thin, right? But if you were to stack 1 billion sheets of paper, it would reach about 100 kilometers high, roughly the distance from the Earth to the edge of space. Now, if you take that same sheet of paper and imagine it as a meter, 1 nanometer would be the thickness of that single sheet. In this realm of the ultra-small, we're dealing with the very building blocks of the universe. We're able to manipulate individual atoms and molecules, creating new materials and substances with properties that can be vastly different from those they exhibit at a larger scale. Consider a grain of sand. On its own, it's just a tiny speck. But under a powerful microscope, that grain of sand reveals a world teeming with life and activity. At the nanoscale, that grain of sand could be a powerful computer chip, a medical device, or a piece of a solar panel. The world of nanotechnology is a world of infinite possibilities. It's a world where the smallest particles can have the biggest impact. It's a world where we can shape the very fabric of reality, one atom at a time. So, in the realm of the ultra-small, we have the ability to manipulate individual atoms and molecules, a truly mind-boggling concept. What if I told you that this technology, operating on such a minuscule scale, has the potential to revolutionize our world? Welcome to the realm of the nano, where science and technology converge to work magic on a scale so small, it's nearly invisible to the human eye. Nanotechnology, the science of manipulating matter at the atomic and molecular scale, is poised to bring about a revolution in various fields. Let's start with medicine. Nanotechnology offers the potential for targeted drug delivery, minimizing side effects and maximizing effectiveness. Imagine a world where tiny robots or nanobots swim through your bloodstream, seeking out and annihilating disease cells. Now let's talk electronics. As we continue to demand smaller, faster, and more efficient devices, nanotechnology steps up to the plate. It allows for miniaturization while enhancing performance, leading to powerful computers that fit into the palm of your hand. In the realm of energy production, nanotechnology offers a game changer. It could lead to more efficient solar panels, batteries with greater storage capacity, and even the extraction of energy from unconventional sources. Don't forget material science. Nanotechnology is enabling the creation of materials with unique properties. Think of self-cleaning surfaces, clothes that resist stains, or glass that repairs its own cracks. Nanotechnology is also making strides in environmental protection, with the potential to clean up oil spills, remove pollutants from water, and even capture carbon dioxide from the atmosphere. In essence, nanotechnology is like having a magic wand that allows us to manipulate the world at the most fundamental level. It's a tool that could lead to unprecedented efficiency and capabilities, transforming our world for the better. But as with any powerful tool, it must be wielded with care. The potential benefits of nanotechnology are vast, but so too are the challenges and risks. And that's a topic for our next scene. Indeed, nanotechnology holds the promise of transforming our lives in ways we can barely begin to imagine. With every tiny step we take in this field, we move closer to a future that, just a few decades ago, would have seemed the stuff of science fiction. Now, you might be wondering, how do we even begin to manipulate matter at such a small scale? To unravel the science behind nanotechnology, we need to dive into the world of the ultra-small, where things behave differently than what we're accustomed to in our macroscopic world. At the nanoscale, the rules of quantum mechanics take the lead, giving materials new properties and behaviors. It's an entirely different ballgame. But to play in this field, scientists needed to develop tools with the ability to visualize and manipulate particles at the nanoscale. Enter the scanning tunneling microscope, or the STM, and the atomic force microscope, or the AFM. The scanning tunneling microscope, invented back in the 1980s, was the first tool that allowed scientists to see individual atoms. It works by scanning a sharp tip over a surface. The tip is so sharp that it ends in a single atom. By applying a voltage, a quantum mechanical effect called tunneling allows electrons to move between the tip and the surface, creating an electrical current. This current changes as the tip moves over atoms on the surface, and by measuring these changes, we can map the position of atoms. On the other hand, the atomic force microscope, AFM for short, uses a very sharp tip that is attached to a cantilever. As this tip scans across the surface, the cantilever bends due to the forces between the tip and the surface. These bending movements are then tracked by a laser beam, enabling us to create a detailed topographic map of the surface at the nanoscale. These aren't just tools for observation, though. Both the STM and the AFM can also be used to move and manipulate individual atoms. It's like playing a game of atomic-scale chess, where scientists can strategically place atoms and molecules to create new structures and materials. Through these remarkable tools, scientists are pushing the boundaries of what's possible at the nanoscale. However, as with any groundbreaking technology, there are challenges and risks involved. Delving into the world of the infinitesimal, nanotechnology encounters a host of technical challenges. Manipulating atoms and molecules on such a minuscule scale is no easy feat. It requires not only advanced scientific knowledge but also precision equipment, both of which are still being refined. Moreover, the quantum mechanical behavior of particles at the nanoscale introduces a whole new set of rules and unpredictability that we're still grappling to fully understand. But technical hurdles aren't the only issues at play. There are potential health and environmental risks that we need to address. As nanoparticles can easily penetrate biological membranes, there's concern about their impact on human health if they accumulate in the body. The environmental impacts, too, are largely unknown. As these nanoparticles find their way into our water, soil, and air, what will be their effect on our ecosystems? Regulation of nanotechnology is another area of concern. Given the novelty and complexity of this field, current regulations may not fully cover the potential risks and challenges. It's a global issue that requires international cooperation to ensure safety standards and best practices are in place and adhered to. And let's not forget about ethical considerations. As we tread into the realm of the nano, we're venturing into territory that can potentially change the fabric of life itself. Questions about who gets to control this technology, how it's distributed, and its potential misuse are all ethical dilemmas that we need to consider. Despite these challenges, the potential benefits of nanotechnology make it a field worth pursuing with caution and responsibility. As we continue to explore and innovate in this realm, we must do so with an eye towards not just what we can achieve, but also the potential consequences of our actions. It's a delicate balance, but one that we must strive to maintain as we push the boundaries of what's possible in the world of the ultra-small. So, where are we headed in the world of nanotechnology? Well, the possibilities seem as infinite as the universe itself. The future of nanotechnology is a fascinating, complex tapestry woven with threads of innovation, discovery, and the potential to revolutionize many aspects of life as we know it. Right now, researchers are tirelessly exploring the potential applications of nanotechnology. In the medical field, for instance, we're seeing the development of nanorobots. These tiny machines could one day navigate through our bloodstream, delivering targeted treatments to diseased cells, and potentially changing the face of healthcare. Imagine a world where cancer or other diseases could be treated without the damaging side effects of current therapies. In the realm of environmental science, nanotechnology is being harnessed to tackle some of the world's most pressing issues. Nanomaterials are being developed to purify water, absorbing harmful chemicals and leaving clean, drinkable water behind. Similarly, nano-enhanced solar panels are on the horizon, promising to significantly increase the efficiency of solar power, and thus, our ability to harness the sun's energy. Nanotechnology is even making its way into the digital world. The development of nanowire transistors could lead to computers that are faster, smaller, and more energy efficient than anything we have today. This could revolutionize everything from personal computing to the vast digital infrastructures that keep our world running. However, just like any transformative technology, nanotechnology also presents us with a host of new challenges and ethical questions. As we continue to innovate, we must also ensure we're considering the potential impacts on our health, environment, and society. In our everyday lives, nanotechnology could soon influence everything from the clothes we wear, the food we eat, to the cars we drive, and the homes we live in. It's an exciting, albeit complex, frontier. As we venture deeper into the nano world, we're standing on the precipice of a new era of scientific discovery and technological innovation. The future, it seems, is tiny,